Yo, this is question 2 of the 2022 AS Level Physics Unit 1 paper. This is about work and energy transfer. So let's start it off. It gives us a graph, a force extension graph, something we've seen plenty of times in class. It says calculate the work done in stretching the spring 0.4 meters. So I hope you remember that the work done is the area under the graph. So I'm effectively finding that green area there. That's a triangle, so it's half the base, half of that, times the height, which comes out as 0.2 joules. Make sure you get your units right. We're looking at work done energy. Explain why the work done to stretch it 0.8 then. So I've doubled the extension or the stretching. Explain why it's not twice your answer. Okay, because obviously if I looked at this big triangle, half the base 0.4 times the height 2 is 0.8. That is not double the previous answer. And of course that's because not looking at the area under the graph, using another formula for work done, it's half times the spring constant times extension squared. So if I double the extension, my work done is double squared, which is a factor of 4. All right, now we've mentioned that a couple of times in class. They like to ask that, so be on the lookout for it. Next part of the question then is about a car. It's being pulled back, so we're compressing this spring, but you can think of that as an extension. It's a compression, and then we're going to shoot it forward, and it goes around the circle and travels on, okay? They've given us the radius of the circle. They've given us the mass of the car. My gut instinct is we're going to be looking at the potential energy and the kinetic energy of this car at a certain point on this track. So let's have a look what they say. It says the spring is compressed by 0.4 meters. Now that's key. Straight away, we've already worked out, okay, how much work is done or how much energy there is available when it's been compressed 0.4 meters. So we're going to use that answer at some point. The spring is compressed by 0.4 meters. The car is placed at the end of the spring, is then released, assuming that all of the energy is transferred to the car. So that 0.2 joules, all of that is transferred to the car. Calculate the speed at the top of the loop. Okay, now, when it gets to the top of the loop, sorry, not on camera, when it gets to the top of the loop there, it'll obviously have kinetic energy, because it's travelling with speed to get there. But of course, it's off the ground, so it will also have gravitational potential energy. So that 0.2 joules that is transferred from compressing the spring will be converted to the potential and the kinetic energy at that point there. And that is how we tackle this question. So all the energy is transferred. So the 0.2 is the potential energy and the kinetic energy at the top of the loop. Now, the potential energy is its mass. It's 30 grams. Make sure you put it into kilograms. 30 times 10 to the minus 3 times gravity times the height. Now, they've told us that the radius of this circle is 0.25. So at that point, the height there is the diameter of the circle. That's where that 0.5 came from. So that's your mgh. Plus the kinetic energy at the top of the loop, half mv squared, half times its mass, again remember to put it into kilograms, times v squared. Okay, so work that out, press buttons on a calculator, take it over, etc. Bring the half m over, you're left with v squared equals that number there, square root it to get a velocity of 1.88 meters per second. And then the next part, it says, in reality, resistive forces act on the car. The car loses 5% of its initial energy to friction, okay? Now, its initial energy was 0.02, so 5% of that is 0.01 joules. That's the amount of energy lost due to friction. They want to know the mean resistive force, okay? Now, don't forget, the energy lost or the work done due to friction is the mean resistive force times by the distance it has travelled. So if I want to work out the mean resistive force, I get the lost energy and I divide by the distance it has travelled. Now this was a bit cheeky of the exam board. So the distance it has travelled to get from there to the top of the spring is the 0.5 there plus then half the circumference of that circle. That was the distance travelled. So there's my 0.5 to get to the bottom of the loop. Half the circumference is half of pi times diameter. Chuck it in, chuck those numbers in the calculator. It came out as 7.8 times 10 to the minus 3 newtons. Don't forget, we're working out a resistive force. My units is newtons. All right? Not the easiest, not the hardest. Should have picked up marks on that. Nice one.